All right. Uh, yeah. Hi guys. This is Chris from DoraHacks. Welcome everyone to join another workshops for the Movement Hackathon that is going ongoing right now on DoraHacks. Today we're very happy to have Lawrence, which is the co-founder of Henry, as a movement join us and give a workshop presentation about what is Henry and what they're building right now. A little bit more background for the Movement Labs hackathon. It's actually the very first time that for us to support Movement Labs developer initiatives. So definitely super excited about this. And also, I believe this is also the very first Movement Labs hackathon that they have ever hosted in their history. But right now, we have seen a decent amount of the interest that from global developer communities that we have to participate into the hackathons. So if you are developers that either have skills in Solidity or Move language, this is definitely the one that you do not want to miss out. There's a 45,000 prize pool for you to grab. And cannot wait to see the next generation of move dApps that could be potentially emerge through the hackathons. Yeah, so don't want to take too long for the intro. Let's get the stage to Lawrence to start his workshop today. Lawrence, feel free to take care.
Hey everyone. I'm going to share a screen real quick, and I'll give a quick introduction about myself and what we're doing at Henry. Okay. Entire screen. All right, you guys should be able to see that. Perfect.
Yeah, we can see it.
Awesome. All right. I'll give a quick introduction on what Henry's doing, and then I'll sort of go over what it is I want to accomplish in this workshop and sort of what value add that you as like builders in this hackathon will be able to get. So first, Henry is an on-chain super app, and we're dedicated to redefining the future of retail commerce. And we're taking a multifaceted approach to this problem, which encompasses application layer products as well as infrastructure products, which I think is going to be interesting for developers like yourself as we move forward with our infrastructure products. Now, what is Henry? Very clearly broken down. We're composed of three main products. So we have Lux Rewards. It's a crypto native rewards platform for consumers. You can think of this as just being a platform that you as a consumer interact with through an app. And as you shop online, you're able to get cash back in crypto and just do everything that you would need to do in Web3 with those rewards through one interface being Lux Rewards. Next, we have a low-code development platform called Lux Loyalty. And what that does, it's the merchant interface, and it allows brands to seamlessly integrate Web3 elements into their product lines. So what that means is, like, as a brand, I might be curious about utilizing various Web3 aspects in my products. I understand that there's benefit to my products because there's a Web3 ecosystem. There's various standards that are beneficial for my brand, but I don't know anything about Web3. How do I actually get involved in this? How can I tap into, for example, the audience of Lux Rewards? How do I tap into the wider Ethereum ecosystem? Henry Lux Loyalty is essentially like the easiest entry point for brands to get involved. And then thirdly, we have Strata, and this is where our partnership with Movement Labs really shines. It's our layer 2 on Ethereum, and we're building it with Movement's Move Stack, and we're specifically taking advantage of their execution layer. Sorry if there's noise. We're taking advantage of their execution layer, utilizing specifically Move, and we'll get into this later, but I think you guys as like hackathon participants would be particularly interested in Move commerce standards, as there's a lot you can do there, and that stuff that we're utilizing as well in our platform. All right, so let me try to see if I can move this. Or actually, I'll just read it out. Yes, that's perfect. Now, so for this workshop, what value add as a hackathon participant will you be getting? Now, just to recap, Henry and Movement, what we're doing together is that we're, one, Henry will be deploying on-chain components to Movement's M2 when they go live to mainnet. And eventually we're going to be moving the on-chain components to our own L2 deployed with the Move stack. That's sort of the extent of our collaboration. And Henry, as a company, where we're participating in the judging of specifically commerce-related infrastructure projects with this hackathon. And I believe there's a judging criteria somewhere, but with an emphasis on like the innovation, implementation, and business viability of the idea. I'm going to be the one sort of looking through at some of the commerce-related projects in the hackathon, and I'm really excited to see what you guys build. And at this workshop, I'm primarily going to be sharing ideas as well as my experience building commerce on chain with Henry, and hopefully we can sort of inspire somewhat like some interesting builds and sort of show what is really capable with the space. It's going to go from like one simpler idea to a slightly more advanced idea. And the idea is just to show that there's so much that's possible with Movement's like M2 ecosystem, M1 ecosystem, that the limitations are really like they're non-existent. And yeah, and I'm just this is going to be technical, but it's not going to be a coding walkthrough for your information. Now, here's a breakdown of the presentation. We're going to go over briefly what we're actually doing with Henry. What are our products? What do the products actually do? And then why it is we're choosing Movement. And finally, we're going to sort of get into the meat and potatoes. We'll talk about what it's like building commerce on chain and what are some projects and variations of these projects that you could implement yourselves, and how this could sort of be a very viable product in the real world, not just as like a side project. All right. As we're well aware, the current blockchain ecosystem has a few drawbacks where we're still quite early. One of them being relatively poor UX compared to Web2 alternatives. As we understand, passphrases are not so great because there's no account recovery. It's easy to lose. There's also prohibitive transaction fees as well as transaction latency. Also, there's development complexity. So as you guys are well aware, building on-chain requires you to understand potentially large components of the actual underlying infrastructure. And what that does is makes it particularly difficult for Web2 developers, people that are not blockchain native, to actually come on board and develop in the space. And additionally, as we're also well aware, and a problem that Move actually does a great job of solving, is writing secure smart contracts is quite difficult. And because we're in a world where there's like a lot of siloed ecosystems, cross-chain messaging is vulnerable. It's like the second largest attack vector. And overall, you want to reduce the need for like trusted third-party bridging if you can help it. All right, these are all problems, but what we see is that Movement's M2 using Move language, as well as deploying as a rollup on Ethereum and interoping with other rollups, that's a massive advantage that largely alleviates many of these current issues. Now we'll talk about quickly what it is we're doing with Lux Rewards. Once again, Lux is a crypto cashback platform that helps brands find new customers, but it also lets you shop at your favorite brands, and you can earn USDC, ETH, etc. As cashback on every purchase. And then some product features are like industry-leading cashback. You can off-ramp into Visa prepaid card or Apple Wallet, and you can also stake your rewards. And then in our roadmap, we're aiming to do full account abstraction. So Move and Movement eventually is to have their own implementation of ZK login, and that's a type of user account abstraction. And Moves comes with a built-in sponsored transaction like primitive, which allows you to do the, of course, sponsored transaction element of account abstraction. And this is overall really important to the actual end user because you want to obviously eliminate gas. And then also we're going to have a marketplace to trade and exchange rewards. as well as a user merchant data economy. And these are all some actually ideas that I'll touch on in a bit later, and stuff that you can actually try out and build yourselves. All right. As for the Lux Loyalty overview, so Lux Loyalty is an SDK with low-code tooling, and what that does is that it lets brands integrate Web3 functionality, as I mentioned earlier, such as, let's say, token minting, burning, etc., into their existing web applications. And you can sort of like let your mind go wild. They can do things such as license IP, building out brand loyalty programs, as well as like what you call digital twinning or tokenization of physical goods. All this will be reflected on chain, and bring about a suite of like business benefits to the actual merchants. And here's Strata. So Strata is the actual infrastructure that we're building with MoveStack. It would utilize elements such as ZK login, gas sponsorship, and we would go with a multi-proof rollup model. What that means for those that are less familiar, there's like ZK rollups, common example being like, of course, ZK sync. So they're proving every like rollup block and submitting the proof on chain. They're not going with like an optimistic model where you're assuming the transactions within this rollup block are valid. Instead, you're assuming they're not, and you're proving it, and you're having it verified on chain. And the alternative is optimistic rollups, where you're assuming all the transactions are valid, of course, and then you have a window, and then you may or may not have fraud proofs. We're basically combining them. So we add a dispute window, but the disputes are actually handled with CKPs. And there's also like a third element, which is like multi-sig, which a lot of these rollups currently utilize just like only that. But we sort of use it as like one side of like a triangle. And another element that we are able to do is actually cross rollup channel abstraction. So we're actually building out Strata with virtual channels, and I'll actually break down some ideas of how to build state channel applications on Move. And what that does, it allows what channels allow you to do is that aside from making cross rollup interactions easier and safer, you can do basically cost-free peer-to-peer transactions between users on the channel. And if you could think about it in the context of commerce, you could think about it as being basically free transactions between merchants and consumers. And this also, what is nice, actually, you can isolate certain aspects of smart contract development, such as, let's say, I'm building out a lottery, and then you can have like or let's say I'm building out like a raffle. That's, I guess, more accurate terminology for merchants. I'm building out a raffle for a company like Nike. And then for users to actually interact with them, they don't have to have any cost involved because they're going to be using state channels. And because this sort of smart contract logic has been built out already. We'll go into how state channels works, but essentially what you can do is you can interact with the contract, you can engage in a transaction, you can settle the transaction, and you can do it all free. And that's very powerful when it comes to commerce applications. And the final thing about our infrastructure is that we utilize a modular architecture. So we have of course, the Move execution engine, and we're also looking to use external DA as well as shared liquidity through sequencer networks. You might know Espresso as like the biggest one, and what that lets us do is actually accomplish the highly secure, trust minimized cross-chain messaging, and actually abstract the state channels cross-chain. Now let's sort of get into the different aspects of the Move stack or Sui Move in general with M2 that you can use to build commerce-related infrastructure or other applications. And the first powerful elements that are really sort of right in your face and extremely obvious are actually the SWI standards. So what Movement M2 allows you to do, of course, is as a rollup on Ethereum, it basically lets you use SWI standards on Ethereum. And what that lets you do, you get to tap into like one of the largest liquidity, like highly liquid chains, of course, second largest chain. And you can actually use these SWI standards that are built specifically for commerce, including kiosks, closed loop tokens, and object displays. And this actual focus and development of these standards really makes SwiMove the ideal execution layer for commerce. And that's why we're so committed to actually building on Movement Stack, just because all those things complement each other so nicely. And the next is off-chain scaling. So some of you guys might be familiar with Polygon Maiden or Aztec, and something that they are doing is they're doing essentially off-chain private computation that is verifiable on-chain. The ZK space has been progressing somewhat in this direction. And the interesting stuff for application developers such as ourselves is that we can utilize like an optimistic version of this, and we can actually deploy it across different chains. And what you can do is you can just basically design a state channel application, but on the M2 on the M2 rollup. And what that lets you do is you can utilize nice account abstraction primitives such as like native gas sponsorship on SwiMove that lets you actually make the state channel user flow extremely seamless. And final thing that I won't be able to cover today too in depth is actually sort of economies of data. So a very interesting idea, in my opinion, and something that is important for commerce is the custody of data. So you guys might know Honey was like Honey is a very popular cashback app, and it was actually sold to PayPal for like billions of dollars. And a big reason why is because they had customer data in their database, and shopping data is extremely valuable. And they were obviously able to acquire that sort of large swath of data by having the extension installed on your device. But we believe like something that is almost the next level of that, and with sort of like Web3 pilled in there, would be for there to be an economy of data, and let's just say it's shopping data. So what you do as a user is that ideally locally or with a semi-trusted or sort of trust minimized intermediary, you can accumulate the data that your shopping data or activity, and then there's a marketplace. There's like the buy side where merchants are on the market for data from yourself and others like you, and you can actually gatekeep the access of that data with tokens. And the nice thing is that with the scalability of M2 and the actual DA offerings that M2 is planned to have, it'll actually make the storage of data likely to be somewhat economically reasonable. And that, of course, like that's up to you guys to experiment. And I believe it's like quite an interesting application. All right, moving forward. Now let's talk about an RWA's marketplace built with SWI standards. So these are some three SWI standards that are a bit different than what you might find in like the Ethereum Solidity ecosystem. The first of which is kiosks. Essentially, what kiosks let you do is it's a primitive on SWI built specifically for commerce. And what it does, it lets you list items in this kiosk, which you can think of it like essentially a storefront. And you can customize various policies for these objects that you're actually listing in this kiosk. And then you can list things, you can take things off the storefront, and then you can implement royalties and whatnot as things are traded. And the very natural implementation and application of this type of primitive would be to mirror a real world storefront. And of course, this would involve an application where like you as a user, sorry, you as a developer build out a website of some sort or some interface. And as products get added, they're also like represented somehow on chain. And you could do that by utilizing closed loop tokens. So this is a little bit different than normal, what you would almost think of like ERC20 equivalent tokens on Sweetmove. Closed loop tokens essentially adds more guardrails around what can actually be done with the tokens. So it's sort of less akin to cash, and it's more akin to other types of like financial like types of banknotes or something where they can only be like exchanged a certain way. And if you were to go back to the commerce context, you could simply make it so that the kiosk would be offering closed loop tokens, and you could sort of restrict it so that they are only tradable within a certain whitelisted group, which may be used for like a tiered membership program or whatnot. There's a lot of ideas there, and it's nice that Sui makes it so easy to utilize. The next thing is quite similar to NFTs on other chains, but it's essentially just Sui object display. In Sweetmove, like everything is like an object, and then what you can do is you can of course like map it to an off-chain display representation. So it's specifically for off-chain display, and it also allows for dynamic generation of images or whatever the display is off-chain upon token creation. And a little bit how I mentioned earlier, what this allows you to do, you can build out like a phygital goods marketplace where you can combine, of course, the on-chain and off-chain elements. And you could also define custom policies. So let's say I have a shoe and I want it to have specific like trading policies within a certain group of people. And that can also be defined on chain if, of course, that sort of information is being tracked. And because we're starting from zero, we're able to do that, right, with this by building the project like from the ground up. And when you're actually like generating the token for the product, you can utilize these dynamic NFTs, which can then generate an image upon creation. You get creative with that as well. So that's kind of the basic, or less not basic, but it's sort of like the entry level. Get on the Sweetmove, find out where these sort of commerce standards can be used, and just go and build that application. And I feel like this is awesome, and I feel like this is a great way to like start out and build a really cool project for movement. But I think the reason why Henry decided to specifically place like emphasis on like commerce infrastructure for this hackathon is because we're particularly interested in the sort of infrastructure related problems with commerce, in addition to, of course, like all of the UX things. Oh, and there's also some more reading about Sui standards, of course, if you guys are interested. But moving on, because we're like quite interested in commerce, and we believe actually like a major prohibiting factor in the space is the commerce space, that is user experience for merchants and consumers, and how like a lot of the user experience issues stems from like poor finality, slow finality, and expensive transactions. We believe that like a lot of this can be actually mitigated with state channel based solutions. And as it turns out, like a lot of people are not the most familiar with state channels because in the Ethereum ecosystem, it's somewhat less popular. But you guys you probably know about the Lightning Network on Bitcoin, and that uses similar principles to state channels. It's like technically a payment channel, but I think now I'm going to explore what you can do with custom state channel infrastructure on rollups like M2, and why it is M2 makes it nice for you to actually build out state channel scaling solutions. And I would say this is very like clearly classified as like a commerce infrastructure. Hold on, there's comments over here. A commerce infrastructure category for the hackathon. Also, I just joined the comments section. I was looking at private chat. I see Sugar saying G Henry, very awesome. G Henry, back to you too. So yeah, state channels. I'm just going to do a brief overview, and I'll go into sort of some advanced applications and what is interesting in this space with regards to state channels plus M2. So for one, state channels, what they allow you to do is they let you facilitate off-chain peer-to-peer transactions. So what happens is, like, let's say on-chain there is a we're just doing a chess game. I think this is a very simple example, and it sort of it can extend past like chess, of course. But like, let's say there's there's Rust. Let's just say there is a like a chess contract on chain, and what happens is two people have to open the channel. Let's say one user goes and interacts with the contract, starts the chess game. The other person joins the chess game, and what happens is the channel is open. And what that means is that the users are able to transact off chain. Essentially, they're just signing what you call notes and passing them back and forth. You can just be like, I moved the board in a certain, I moved pieces on the board a certain way. I sign it with my digital signature. I send it over to the second player. They do the same. We go back and forth. And then at the end of the game, we're able to actually submit it on chain. And then what happens is the contract is going to verify that the final state was signed by both players. And once the final state was signed by both players, it disperses whatever funds were locked up for the chess game. So like, you'll be able to implement gambling mechanics in this way. But you could also do the same thing, not just with chess. You could actually make it so that you're transacting with like tokens. So like, each state transition, instead of it being a chess move, is transitioning the state of your account. So I'm adding or subtracting tokens. Like, let's say my message to the other person is, I have my balance, I'm updating it, adding tokens into it because we agreed that we're going to exchange token. And then this other person, they update it. Okay, they subtract their balance, they add to, they like just subtract their balance, and then they sign off on that. And then once we have both signatures, we can actually keep doing that infinitely. And we can submit it back on chain. And what that does is that it essentially lets us to do as many transactions as we like off chain, and then have it settled on chain for like whenever we need to go back. So we can think about it like, is that essentially what is happening off chain is that once the like signatures are being when the notes are being passed and the signatures are signed, it's as if you have like a receipt, or you have like a check. That's a good way to think about it. You have a check that you're going to cash, that you can cash at any time. As long as there's both signatures on a consensus state between two parties, once you submit it to the chain, you're then able to get the funds dispersed. And that's why state channels are like being utilized on Bitcoin, because it's like a very, very trust minimized way of scaling the blockchain. Why it hasn't been adopted so much on Ethereum is actually kind of an open question. And I'm in the camp of being like, rollups have been super important, but after sort of rollups have matured, there's still like this last mile that I believe like the industry needs to cross before it can break into industries with like very high transaction volume but relatively low transaction value, and that is where state channels would come in. Oh, and what I just described was the optimistic case. So there's also a dispute resolution case similar to rollups. So as you know, in optimistic rollups, there's fraud proofing that is implemented. It's supposed to be implemented, not implemented everywhere, but there are fraud proofs that are used to essentially allow for a challenge for like the validity of a transaction. The same, it can be done in state channels. And this is usually just called like a challenger or a dispute. Now, I'm going to be going over some sort of updated ideas for how you can improve state channels and what you can actually do to eliminate some issues that you might have with dispute resolution on state channels. So something you could do is that instead of asking the smart contract to actually, let me take a step back. I didn't explain dispute resolution. So for state channels, let me actually go back. For state channels, when you are doing dispute resolution, you have to essentially replay the move that you are disputing on chain. So let's say I do a state transition and it's a chess move, and I play the move so that I cheated. So instead of like moving the knight a certain way, I just put it wherever. The other player can initiate a dispute, and what they do is they call a function on the chain to basically indicate to the other player that they need to answer on chain. That's why it's a dispute. So there's like the person who initiates it, and then there's the challengee needs to go on chain, and they need to play the move to actually settle the dispute, and then the game can continue. And the issue there is you're susceptible to what is called griefing attacks. So when a challenger makes a challenge, the other person has to answer. Otherwise, they're likely going to be like screwed over, and their funds are not going to be dispersed in the way that is supposed to, because they're in a dispute scenario. And the issue there is that like over time, a person who's griefing this project, they can initiate a bunch of challenges, and what that's going to do is going to basically it's going to tank the user experience, and it's going to make it just as expensive as doing everything on chain. And so what we're actually able to do here is we can do a sort of modified dispute resolution mechanism where we can cap the number of challenges back and forth to, let's say, like K occurrences. This constant can be figured out from, I guess, like data analysis of the actual behavior of users on the platform. And instead, you can, after K occurrences, you can start a ZK prover to actually prove the entire execution off chain. And what that does is goes back to the models that other rollups use, like maybe Aztec and Maiden, where they're actually proving the entire off chain components with ZK. But here it's only used as almost like in a dispute resolution case where you use ZK, a little bit similar to the multi-proving model in rollups. Additionally, you can also add a DA element to this. I didn't talk about this so much, but what you're able to do is a way of making a way of constructing the proofs is you basically need to add the entire transcript of transactions into the proof if it's supposed to be proven on chain, and that gets costly if it's going to be stored on the actual blockchain itself. So it's advantageous in some cases for you to actually use an external DA service for you to actually store the data before it's added to the proof. And you might think like adding an additional DAC, that's kind of expensive, but what you can actually do, you can use eigenlayer AVS, and you can sort of have an established staking economy without needing to, like, you can solve the validator sort of like acquisition problem with AVS, and you can make the incentives and gas structures work in this entire like system together. So yeah, that's the dispute scenario where there's a need for like proving one execution with ZK. And then the other scenario that I mentioned was you're essentially proving the entire transcript with ZK. So now, like after k occurrences, instead of proving one move with ZK, we're proving the entire rest of the game with ZK. And what that lets us do, it eliminates the need for challenges to go back and forth. So you're not going to actually disturb the flow of the game, and you're not going to be susceptible to griefing attacks. The trade-off here is that proofs are going to be needed to be computed, but the actual cost of that can sort of be done. It sort of can be gamed in a way because it's all off-chain. And yeah, so you can learn more about state channels there. I added some resources, and yeah, that was the bulk of the talk. And so you can learn more about Henry here, have our Discord and homepage. I'm not sure if this slide deck will be shared, but there are like resources to learn more about what I talked about in the actual slides. And just to sort of conclude with Henry, we're building application layer products. We're building commerce solutions that are based on blockchain that consumers and brands can utilize to enhance their day-to-day lives and enhance their actual top-line revenue. And we're really excited what Movement has going on. And like a big reason why we partnered with Movement in the first place is because the tech is really robust and it's extremely promising. Like adding Move to Ethereum via rollup and building out the Move stack just allows for so many interesting business opportunities in the space. And that's sort of why I wanted to share a bit about commerce-related applications that you guys can build as a part of the hackathon, and overall, like share a little bit about my enthusiasm for why it is like I find it so interesting, and I guess illuminate the different areas that we're particularly interested for, like I guess the hackathon judging. Overall, really happy to be here and excited to see what you guys build.
Yeah, great. Thank you very much, Lawrence. I think we are a little bit out of the time, but I guess I can have one question for you. So just general, I think you have mentioned a little bit about what like this as well, but I'm actually very curious to hear like what do you think could be the most exciting application that can utilize your infrastructure to empower like the e-commerce relevant dApps? Yeah.
Thanks for the question, Chris. So some use cases that we're looking at, it's sort of like focused on brand loyalty first. But what really excites me about the infrastructure, besides the use case of brand loyalty, which is like me as like a brand wants to improve my customer lifetime value, and then I can issue some sort of like tokenized like coupons or discounts through my platform. Then this can be passed on like and traded in the open Web3 like marketplaces, and then like it benefits the user because you can actually exchange rewards, and then it can benefit the brand because you can actually get like a royalty on trading and whatnot. That is the initial use case that really excited us. But over time, we found that like with this infrastructure, it was more capable than we initially thought. I think like we through our research, we've realized it's more interesting to generalize. And so what we want is that Lux loyalty and the underlying infrastructure will like power like a Web3 Shopify. So like Shopify, as we know, like empowers businesses of all sizes to basically like bootstrap their I guess payment infrastructure, loan infrastructure, website, all that. What's actually possible with specifically like virtual channel scaling or off-chain scaling of rollups is that it lets you to largely eliminate the Web3 like variable gas issues, the high cost of transactions because you can eat to the cost as like an infrastructure provider and charge a subscription fee. So you can basically mirror what is being done in Web 2, except like I said, like you have like this check that you can cash whenever. It basically gives you the capabilities of Web 3. The only work that you have to do is that, like from an application developer perspective, for us to do like a lottery or a ticketing system on this Web 3 Shopify, we need to actually build out the on-chain smart contract applications first, and then basically give developers like tools to hook into that. That's sort of the trade-off you make, but I think that's well worth it given the potential of what can be done.
Yeah, that's definitely sounds like a very interesting utilities. Cool. I guess we can wrap up here. But really appreciate, Lawrence, your efforts and time to join us to give such a good workshops to our audience and developers. For all of the audience, like if you are interested to get connected with Lawrence, or I guess want to build something really cool that leverage Henry's stack to build next generation e-commerce apps, I think the most direct way is that you should definitely join the hackathons, submit one of the projects that you think is really cool, potentially that you can win the hackathons, get some exposures, and keep building for the future of the e-commerce and move ecosystems. Or like Lawrence mentioned, there are a couple ways that you can get in touch with Henry's team, either through social medias or other channels. And I believe they're more than happy to engage with you guys as well. Yeah, so I guess looking forward to see all of the exciting projects, e-commerce project that leverage move stacks during the hackathon. Yeah, last but not least, G Move, G Henry, and hope you guys can all have a good day.
All right, thanks again, Chris. Pleasure being here, everybody.
Thank you, Lawrence. Thanks everyone. Cheers. Bye bye.